Section P5 starts with a real basic introduction to slope and the slope-intercept form of the equation of a line, which of course you guys know, but I'll just write it down here anyway because it's official notes. Y equals mx plus b, whereby m is the value of the slope of the line and b is the value of the y-intercept of the line. Okay, I trust that you guys know that backwards and forwards, so I'm going to go ahead and skip example 1 and 2. I do want to talk a little bit about slope, which on page 51 they talk about it. So conceptually, slope just refers to the ratio of the amount of change there is in the vertical component of a line to its to its horizontal component. In other words, it's the change in y over change in x. Change in y, you guys have probably seen the formula look more like this: y2 minus y1 over x2 minus x1. But that's essentially the same thing. So it's the change in y over the change in x. So as an exercise, you should probably just pause this real quick and look over example 2 to make sure you know how to plug in values to calculate slope. And also what example 2 does is it gives you the examples of 4 different types of slope. A line that has a positive slope, a negative slope, a zero slope, and a slope that is undefined. Okay, the topic I want to go to next is another form of the equation of a line. So you already know the slope-intercept form, which is y equals mx plus b. And now we're going to talk about another form called the point-slope form. Okay, so the point-slope form. Now, you can memorize it. It's not that hard. I'll go ahead and write it in. Y minus y1 equals m times x minus x1. Okay. But what you should realize here, and I don't know if you've ever made this connection, is that basically, if you take your slope equation, right, this, and instead of using a specific point called x2, y2, if you just call this y, just a general y and a general x, and then you just multiply both sides by x minus x1, or in other words, you could also put a 1 under this and cross-multiply this proportion, you obtain y minus y1 times 1, and then m times x minus x1, which of course is exactly what the point-slope form is. So the point-slope form is just a derivation of the slope formula. But it's handy to use when you want to write the equation of a line and you know the slope and you're also given a point. So let's go ahead and look at an example of that, example 3. I'm sorry about that. So in example 3 we have, they want us to find the slope-intercept form of the equation of a line that has a slope of 3 and it passes through a point 1 comma negative 2. Now of course you could do this 2 ways. You could just go straight to the y equals mx plus b slope-intercept form, or you could do the point-slope form. My personal preference when we're dealing with a situation where you have a point and you have a slope is to use the point-slope form. Okay, so using the point-slope form, you'd put 3 for m, you'd put 1 for x1, and you'd put negative 2 for y1. So now your equation looks like this, and then you just simplify it. So it's y plus 2, distribute this, and then subtract 2 to both sides, and that gives you the slope-intercept form. Okay, if you want to solve for the y-intercept instead first, and then go back and plug everything in to get the equation, that's perfectly fine too. So now we look at parallel and perpendicular lines. So parallel lines, we know, are lines that have the same slope but different y-intercepts. Perpendicular lines are lines whose slopes are opposite in sign, so one has to be positive and one has to be negative, and they also have to be reciprocal of each other. Okay, that's when you have non-vertical lines, of course. So in example 4, they give us a point, and then they give us an equation of some other line. And what they want us to do is find equations of lines that go through that point that are perpendicular and also parallel to the given line. So the first thing you should do is take the given line and figure out what the slope is. So we can easily do that by isolating y. So you divide by -3, so this becomes positive 2/3 x plus 3. So you can see that the slope of the given line is 2/3. So for part A, where they want you to come up with a parallel line, we're going to use the same slope. So we're going to use the same slope, m equals 2/3, and we're going to use the point 2, -1. Okay, oh boy. So I'm going to go ahead and plug that into the point slope form. So that gives me y minus -1 equals 2/3 x minus 2. Simplify. We're going to subtract 1, and we get this. So there's our parallel line. And then for B, they want us to write the equation of the line that's perpendicular. So the slope now, instead of being the same 2/3, of course, is going to be the opposite sign and reciprocal. Okay, and we're also going to use that 2, -1 point. So this one gives us y plus 1, distribute, and then subtract 1, and there is our perpendicular line. The next topic is just applications of slope, and so we can use slope two different ways. Slope can be a number that refers to the ratio of two things, or it can represent the rate of change between two things. Now, when it's a ratio, it means that the two things that you're comparing have the same units. When it's a rate, it's when the two things that you're comparing have different units. So you could look at example 5 and example 6. Just pause this and just kind of read over those real quick, and you'll get the idea. And the final topic in this section is making predictions. So example 8 is a good example of this. I recommend that you read over it. Essentially, the idea with this is they'll give you two data points, and they'll tell you to assume that the sales or the population or whatever they're measuring either grows or declines linearly. So that means that you can use a linear model to represent the situation. So you come up with your linear equation, and then once you come up with your linear equation, then you can make a prediction about what happens either within the data or outside of the data. And those two things have different names for it, which I think you should know. So if your data points look like this, let's say, okay, and so your linear model would be like this. If you want to make a prediction where the data point is between those two other points, okay, so here's what I mean by between. So let's say this is one x value and this is another x value. If you want to predict what happens at some other x value inside of those 2 points, this is what we call a linear interpolation. Okay, whereas if you were to try to make a prediction of what happens beyond these points, so let's say this line continues, and you want to predict, okay, well, what's going to happen 10 years later? So you kind of look out further, and let's say 10 years later represents this point. So when you're extending the line beyond the 2 points that they gave you, that's called a linear extrapolation. Okay, now both of those are fairly trivial, simple types of problems to do when you're talking about lines. So yeah, go ahead and look at example 8 and just read over it and make sure you understand it, and you should be good to go. All right, have a good rest of your day.